Hello, welcome. Today we are here to discuss about the question called sort the array, where array contains only zeros and ones. Array contains only zeros and ones. So basically, if I give you an example, a equals to, it contains 0, 1, 1, 0, 0, so on like this. So this array only contains these two values, zeros and also ones. Okay, so this is what the question is about. I know you have your answers ready for this question. So when you see this sort itself, you will say me, okay, we already have different sorting techniques, right? We already have different sorting techniques. Like, so if we say bubble sort, hmm, quick insertion sort, okay, selection sort, quick sort, merge sort, bucket sort, heap sort, so on. So on. We have a list which is never ending here. So these are the sorting techniques that we already have. So you'll be saying that, okay, we'll use one of this sorting technique. We will use one of this sorting technique. We will solve this particular question, right? But, but what is the time complexity that is taken? Like on an average, if you choose the best sorting technique from the available sorting techniques, the time complexity will be n log n, n log n, right? It will be n log n. The worst case or the best case, that whatever you choose, it will be big O of n log n, right? So the time complexity will be n log n. So that is true. We can sort this array by using these sorting techniques, and the time complexity will be n log n, right? Now, what is the question is there any way, or is there any simple, or like not simple maybe, is there any approach where we can sort these zeros and ones without using this technique? Without using these techniques, is there any way? Can you think of that particular technique, guys? I'll give you a minute or so. Just pause the video and think of the any approach that we have. So the clue for this question is we only have zeros and ones. Okay, we only have zeros and ones. Only two values, sorry. Only two values. So pause the video for 1 minute and just check, just think of the approach. Is there any? Okay, I hope you have done that. If you haven't find the answer, let's figure out the answer now. So, okay, let me clear the board. Yes. Now, let's take an array, guys. Let's take an array. So, let's take array equals to 0, 1, 1, 0, 0, 1, 0, 0, 1. Right. So, this is the array. Okay. This is the array that we have. This is the array that we have. Okay. Now, now the point is we need to sort this array without using any sorting technique. Without using any sorting technique. That is the thing. As I said, what will be the technique, guys? What is the clue that we have? The clue that we have is it will have only two kind of values, where one is 0, the other one is 1. The other value is 1. Now, coming back to our approach, let's see what we can do. So let's think. So as I know, after sorting this array, I'll have an array like this: 0. So let me check: 1, 2, 3, 4, 5, 2, 3, 4, and 5. After that, 1, 1, 1, 1. So whatever that we have thought here. So what I did, I have counted how many zeros are there. 1, 2, 3, 4, and 5. I placed 5 zeros in the front and remaining values as ones. That's all right. So the same thing, whatever that we did to convert this array into this array, we can do the same array, same thing. So the simplest way here is, the first simplest way is count for number of zeros. Okay, we know array's length. What will be the array length, guys, here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Array's length is 9 here. So we know array's length, which is 9. Okay. Now count for zeros. Count for zeros, guys. This is 0, 1, second 0, third 0, fourth 0, and fifth 0. We have how many zeros? We have 5 zeros. 5 zeros. So obviously, what will be the remaining values, guys? What will be the remaining values? 9 minus 5. What is the answer? 4. What all these 4 values will be like? These 4 values are ones. These 4 values are ones. So this is the simplest approach that you can use to sort the array. To sort this array, where it only contains two kinds of values, that are zeros and ones. That are zeros and ones. So I hope this is clear. Let me note down the same thing here. So the first step is find array's length. Find array's length. Okay. After finding, obviously we know the method called array.length. After that, what we need to do? Count for number of zeros. Count for number of zeros. And now calculate number of ones. How you will calculate? How you will calculate, guys? How you will calculate? Ones count equal to total length minus number of zeros. Obviously, that's all right. Obviously, this is the formula or whatever you can call. So just give me a second. Okay. Okay. Let me. Okay. So first step is find the array's length. Second step is count number of zeros. Okay. First step is find array's length. Second step is count number of zeros. Okay, just give me a moment. Let me write it down here. Find array's length. Right. What is the second step? Count number of zeros. After that, calculate number of ones. How we will calculate? We know what we will do. Number of ones equal to total count minus zeros count. That's all. Total count minus zeros count. We got the answer. Now what we need to do? We need to iterate on array. Iterate on array. Okay, iterate on array and replace the first values with 0 till zeros count. Zeros count. And from there, replace ones. Replace ones. That's all. I hope this particular thing is clear to everyone. So if not, let me take you through an example, guys. So let's take an array. 0, 1, 0, 1, 0, 0, 1. So this is the array. This is the given array. A, R equal to, this is the array. Okay, what is the first step? The first step is find array's length. What is the first step? Find array's length. What is array length? This is 0th index, first, second index, third index, fourth index, fifth index, and this is sixth index. So total elements are, total count is equals to how much? Total count is equals to 7. Total count is equals to 7. Okay. Now Total count is 7. What is the zeros count? What is the zeros count? I'll iterate on the array now. Now I'll go to the first element. Okay, this is 0. Count will become 1. I'll go to the next element. This is 1. So I'll not increase my count. Now what is the next element? This is 0. Okay, the count will become 2 now. I'll go to the next element. And this next element is 1. Okay, I'll not count. I want to count zeros. Now I'll go to the next element. This is 0. So increase the count. So this will become 3. Now I'll go to the next element. This is 0. So I'll increase this count to 4. I'll go to the next element. It is 1. So I'll simply say count of zeros is 4. Count of zeros is 4. What is the ones count? What is the ones count? We know, right? What is the formula? Ones count. Number of ones equals to total count minus zeros count. What is the total count? 7. So let's take 7 minus 4. 7 minus 4, which is equals to 3, which is equals to 3. So total count is 7, zeros count is 4, ones count is 3. Okay. Now, wow, what is the next step? What is the next step? Okay. Next step is iterate on the array, replace the first values with 0 till zeros count. Okay. So till we are going with zeros count. So how many zeros are there? 4 zeros are there. Okay. So the first 4 values will become 0. So this first value will be replaced with 0. Second value will also be replaced with 0. Third value will also be replaced with 0. Fourth value will also be replaced with 0. So first 4. So 4 values are there. Okay, I have replaced the first 4 values. Now, what about the remaining values? Remaining values should be from there replace with ones. So after this 4 indexes, remaining indexes will be replaced with 1. So this 0 will be replaced with 1. This 0 will be replaced with 1. This one also will be replaced with 1. Now if you observe, we got our sorted array. Zeros and ones. Zeros and ones. Okay, I hope this approach is clear, guys. This is a basic approach where the time complexity will be to count number of zeros. We will take an array n times and follow basically n times, and to replace also we take n. So it will be 2n. It will be 2n, which means in total it will be big O of n. In total it will be big O of n. I hope this approach is clear. Now let's see another approach where we will be using two pointer technique. Two pointer technique. Okay. For that, let me take an array, guys. 0, 0, 1, 0, 0, 1, 1, 0, 1. Okay. Why I'm saying this two pointer technique? Okay. From the given first example, if you observe, after sorting, what will be my array looks like? After sorting, how my array will look like? The first half will have zeros. Next half will have ones. There are two halves. Okay. Now what I will do, I will place two pointers, one in the beginning, one in the end. So this will be pointer 1 and this will be pointer 2. Okay, pointer 2. Now, what we will do. So I know left side pointer should always have zeros. So what is the value that I have on the left side pointer? It is 0. Okay. If it is 0, that is fine. I'll move to the next element. Now it is 1. Okay. Now it is 1, which means I should not have 1 on the left side mostly. Okay. Now what I will do, I'll check with the right pointer. What is the value it has? It have 1. Okay. Right side, we should always have 1 only. So I'll go to the next element. Now it has 0. Okay. Now if you observe, P1 is pointing to 1. P2 is pointing to 0, which means I can swap these two elements. I can replace this with 0. I can replace this with 1. I can replace this with 1, which means from the left side, we will be searching for the value 1. Whenever there is 1, we will stop. and from the right side, we will search for value 0. We will search for value 0, which means if the value is 1, simply skip this element, go to the next element. Now, after replacing, obviously this array is sorted. So let's take one more example to make it clear for you guys. So 0, 1, 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. Okay. Now, what we will do is let's place two pointers in, one at the beginning, one at the end, one at the beginning, one at the end. Okay. Now, after placing two pointers, sorry, what I need to search for, left pointer should always point to a value which is 1. So this is 0. Obviously, I don't have a problem with 0. I'll go to the next value. Now, my right pointer, this is pointing to 1. That is fine. But I should swap this 1 with 0 on the right side. 0 on the right side. Now I will check my pointer 2 is pointing to 0 or not. Yes, obviously it is pointing to 0. I will swap this 0 with 1, this one with 0, this one with 0. Okay. Now again, I'll move one step ahead, one step ahead. So pointer 2 is pointing to 1. Pointer 1 is also pointing to 1. Now, if you observe, this I need to replace, but this I should not replace because this is obviously 1. I should keep only ones. So I'll go one step back. Now this will be P2. This will be P2. Now, if you see, I am pointing to 0. So this will be replaced with 0. This will be replaced with 1. This will be replaced with 1. Now, my pointer 1 and pointer 2 will be crossing each other. Pointer 1 and pointer 2 will be crossing each other. So when this pointer 1 and pointer 2 crosses each other, we will stop the process because we already know from left side we are coming. See, pointer 1 is coming from the left side. Pointer 2 is coming from the right side. Once they meet like this, what does it mean? Once they meet like this, what does it mean? This means that the left side all are zeros. Left side all are zeros. And the right side all are ones. Right side all values are called as ones. So we will stop after this particular place. After this particular place. Now let's move on to coding, guys. So let's create an array. 0, 1, 0, 1, 0, 1. Okay. Now int n equal to array dot length, int I equals to 0. Let's take pointer 1 equals to 0, pointer 2 equals to n minus 1. Okay. Now while I'll using a while loop. So till P1 is less than P2, we will do this process. Why? Once this P1 is equal to P2 or greater than P2, we need to stop. We know, right? We have just seen now. We have to stop when they are equal or when they are crossing each other. So we will do that. So first thing is I'll check whether my array of P1, whether my P1 is pointing to 0. If it is pointing to 0, what I need to do? I'll simply move my pointer P1. My pointer P1. Okay. Let's say else if array of P2 is pointing to 1. If it is pointing to 1, what I need to do? I simply move it inwards, P2 minus minus. Okay. Else if array of P1 is pointing to 1 and array of P2 is pointing to 0. Okay. See, initially it is pointing to 0. If it is 0 left side, just increase the pointer. If it is 1 on the right side, decrease the pointer. If left side is 1, right side is 0, what we need to do? We need to swap them. Obviously, we only have 0s and 1s. So what I'll do, array of P1 equals to 1, sorry, 0. Array of P2 equals to 1. This is a simple swapping, guys, because we only have two values. I just did like this. And after that, what I need to do, P1 will be plus plus, P2 will be plus plus. Sorry, minus minus. This will be decreased. That's all. Now, after the entire while loop, let me print this array. I equal to 0, I less than n, I plus plus. System dot out dot print line array of I. Okay, let's this is int I. Let's run this. Now we can see this array we have sorted. This array is sorted. All zeros came first, all ones came in the end. So these are the two approaches, guys. This, if you observe, it only takes n times. It only takes n times because within one iteration we are getting swap all the values. So I hope you understand the logic. Thank you. Bye.